make the delta G negative, and then spontaneous. Okay? Which makes sense, right? From solid convert to gas, you do need to heat it. You need high temperature. And then the third one, gas, gas, gas. Okay, and it tells you this is an endothermic. So it tells you means your delta H positive. How about my delta S? The more gas you have, the larger entropy you get. So 2 plus 1 gets 3 here over 2, right? Delta S. Delta S also positive. So now the same as the second one, right? So high temperature. Okay, high temperature. So the last one, gas becomes this. If I tell you it's also an endo, also an endo. So your delta H, since it's an endo, and usually you break the bond, right? So you also need to form a positive delta H. So what is delta S? Positive 2 hydrogen gas, hydrogen atom gas. Right? So the same as this, you need a high temperature. So that is the way you may, the type of question you may have in your test. Right? It tells you, gives you the reaction. It may ask you which statement is true or false. And so you have to know how to determine that. Another way to work with some problem is you can use this equation or this temperature dependent to determine which temperature you need to make the reaction spontaneous. For example, this one. So you're given, okay, this reaction, delta H negative, right? Delta H is given, it's a negative number. And delta S is also negative. Oh, both negative numbers. Ask you determine the maximum temperature when it is spontaneous. It says maximum because when they are both negative, we need a low temperature, right? When they are both negative, we need a low temperature. Then you got a maximum temperature. That means below that temperature, this reaction can always happen spontaneous. Okay? Let's see which temperature do I need. Let's say number 1. Okay? It's for me. So this reaction, solid, 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 solid. Alright, so all solid, and you're given delta H, delta S. So the equation that connects delta H, delta S, temperature, and related with spontaneous, that is your delta G reaction, right? Alright, so this reaction. To make the reaction spontaneous, what should happen to your delta G? Positive or negative?
Negative.
Negative, okay, I need a negative delta G. When delta G is, is negative, means your delta H minus T delta S should be negative because they're equal, right? So okay, now my delta H is given, delta S also given, so I just plug in the number. Here, must be careful for the unit. The delta H is kilojoule. However, your delta S given is in joules. To make them in the same equation, you have to make sure they have the same unit. Okay, you have to make sure they have the same unit. So let's say because delta G also usually have a kilojoule, so I'm going to convert this joule per K become kilojoule per K. Okay, so we're going to have 41.3 times 10 to negative 3 divided by 1,000, right? Kilojoule per K. And this comes from this joule per K. I convert it to the kilojoule per K. Okay? So now for the kilojoule minus my temperature, I don't know, but times delta S is negative 41.3 times 10 to negative 3 kilojoule per K. Okay? So convert joule to the kilojoule. So I need this number to be smaller than 0, negative. So now what you're going to do? I'm going to move this whole thing to the right. Okay, I'm going to move this whole part to the right. So which means negative 4. Now it's smaller. When you move, this negative sign becomes positive, right? When you move. So it becomes T times okay? Here, I just move this whole thing here. So now, because we need to find the temperature, so I'm going to divide it this factor. So which means divided by this whole thing, okay? This negative 41.3 10 to negative 3 kilojoule per K. And here becomes T, right? But on the right side, since you divide it by a negative sign, so this negative sign here, this smaller sign here should become a positive. I mean, the opposite sign, larger sign, okay? Because you divide it by a negative 41, okay? So now it becomes a larger than T. Okay, so here is a smaller, but you divide it by a negative number. So the sign should be opposite. It becomes larger than this T. Alright, so now you just solve this number here. So you got 20523 K larger. So this is the maximum temperature because T must be smaller than this number, right? So this is your maximum temperature. Okay. Any question here? So key points, there are 2 key points. First, you must know this equation you need to use, right? Temperature, connect all these 3 terms. And second thing, you have to be careful the unit. Convert joule to be kilojoule. Or of course, you can convert the kilojoule to be joules. So either way, but make sure the units must be consistent. Okay? So now you solve the maximum temperature. So now let's say number 2. If you're given a temperature 25 degrees, ask you calculate delta G and determine whether it is spontaneous. This way we are more familiar with, right? It's much easier for you if you get the second question directly, just plug in the equation. So everything is given. So delta H, again, make sure the unit is consistent. So minus temperature, 25 degrees to 98 Kelvin, right? Times, again, I convert it to be kilojoule. Times 10 to negative 3, okay? Convert it to be kilojoule. So then you get, I get a negative 835 kilojoule. Since it's a negative, it's spontaneous. Right? And if you compare this number to the previous number, it is smaller than this number, so it is spontaneous. Okay? So that is how we use this equation to solve problems related with temperature. So the second one actually is easier, right? You just plug in the number, get your delta G, then you determine the spontaneity. The very important thing, keep the unit consistent. If here it's kilojoule, here also kilojoule. If you don't want to convert kilojoule, it's okay, you convert this to joules, but it must be consistent. Excuse me, any question? Okay. So if you want to practice more in the PowerPoint, there are quite a few similar problems. So here you have a positive delta H and a positive delta S. So if you're given temperature, just apply this equation and again make sure the units are consistent. This not right, kilojoule, joule. So make sure in this question they convert kilojoules to joules. So and more questions, right? So here you can go. Okay. This one is very similar as the one, question number 1 we discussed. Okay? Determine the minimum temperature to make it spontaneous. Because here you get positive, right? You need a high temperature. Okay, so you can go back, work with this problem. Okay? And you get more actually. More good. This is the one we discussed. Right? This is the one we discussed. So there are a lot of similar problems you can practice using the PowerPoint. So any question related with this equation? Basically determine the spontaneity, right? Okay. So next, since we know, okay, we use delta G to determine the spontaneity. So how to calculate delta